guys, good morning. So what I wanted to do here was just quickly go over some of the concepts in Chapter 4, which is the Chapter 5 in textbook page 194. So basically what I left for you was two of these online modules that I wanted you to go through, and hopefully you're still going through them. There's two of them, and basically they teach you how to find a linear system. Okay, so your goal for, after completing those two modules is to figure out how to find the intersection point of two lines. So essentially what happens in a nutshell is you've learned so far how to draw one line. Okay, and in grade 9 you touch on this a little bit. So we'll call this line 1. Okay. You then graph a second line, and we call that line 2. So what exactly you're trying to find out is where they intersect. So where those two lines intersect each other, and they created a coordinate of x comma y. Okay, so that itself is the point of intersection. Okay, there are a couple ways that you can do this, and there are 3 ways, in fact, that Chapter 5 in your textbook focuses on. The first way is to graph both lines and seeing where they intersect. Okay, so just doing rise over run, seeing where they intersect. The issue with this method is you got to keep going on and drawing these lines, so that might mean running out of grid space until you actually do see where they form the intersection point. The 2 newer ways are things that are taught in the grade 10 program. The first being substitution. So with substitution, you use algebraic steps, and they help you find where that point of intersection is using a cut and paste method. Okay, so I'll show you how to do that. The module just go through what that does look like. And then there's also an elimination method. It's a little more trickier than substitution. However, it still uses algebraic steps to figure out where, in fact, that point of intersection is. Okay, and that point of intersection will always be in the form of x comma y. So, for example, it could be 2, 3, -8, -4, wherever it lies on that Cartesian plane. Now, the reason why I'm going so briefly over this is it's not a big aspect in these courses, okay? So next year you might be taking 11 mixed math, 11 college math, and then grade 12, if you choose to pursue grade 12 math, you could take the 12 college, or you can take the data management. Okay, the data management is a U course, but if you take the data management, that would have meant you had to go through the M course to get there. Okay, so I just want to talk about your options so that you are aware. It's not a big concept, which is why I'm just lightly treading over it. But I still want to just teach it to you so that you have some exposure to it. We're not going to do an assignment. We're not going to do a test on it. It's just for you to go through those modules, watch this video. If you want, you can try a couple questions in the Chapter 5 on page 194 amongst those couple of sections. You're always, welcome to do that, just to kind of test yourself and see where you're at. However, it's not a big idea. Okay, so tomorrow, which is Thursday, April 23rd, I will start our new unit, and that we'll have a heavier focus on because we'll be talking about quadratics, which is something that is more of a focus in your grade 11 program. Okay, so because linear systems, which is Chapter 4 for us, but Chapter 5 in the textbook, is not a huge focus, I'm just going to lightly skim over it, just so you're still learning it. However, it's not a big deal, okay? So please just watch this video, and I can walk you through a couple of examples and teach you exactly how you would find your point of intersection in case you do come across it in your grade 11 and 12 year. Okay, so for this, I'm just going to reference a couple points. Okay, so we can take a look at, in your textbook, page 202, number 4C. Okay, so basically I'm just going to do one of each type. So I'll do one question where you're graphing, and you're going to see where they intersect. we'll do one where you're going to use substitution method, and then one where you use elimination method. Okay. So first I'll just draw a Cartesian plane. I apologize if this line is not the straightest. Let's try again. There we go, that's a little better. That's good enough. Okay, so we got x, and then we got our y. So we basically have two equations that are given in 4C. So we have to find where the point of intersection is between y equals 2x plus 1 and 2x plus y equals 1. Okay, so first actually what I'm going to do is I'm going to take our second equation and I'm going to transform that into y equals mx plus b. So we have 2x plus y equals 1. I'm going to swing that 2 to the right side, so I actually have y equals negative 2x, because it does cross that equal sign, plus 1. Okay, I'm then going to go and graph both equations. So I'm going to start with our first equation. So y equals 2x plus 1. So once again, you start your y-intercept. We'll just assume every box goes up by 1 unit. Okay. And then we're going to go up 2 over 1. Up 2 over 1. Up 2 over 1. And I want to make sure I go in both directions. So I'm going to go down 2 from 0, 1, over 1, down 2 over 1, down 2 over 1. Now, when we were in class, you guys actually did this quite well. Okay, so this is line 1. Okay, I always recommend that you use a ruler. Maybe I'll try one more time with that line. Just a little harder on my app. Okay, we'll just have to deal with that. Okay. And then we will go and graph the second line. Okay, our second line, once we rearranged it, was at negative 2x plus 1. So, already, I'm going to plot my y-intercept. I'm going to go up 2 over 1, up 2 over 1. Now, you might notice, we'll miss it already overlaps. So, this is actually a very straightforward equation or question where we actually see our point of intersection is at 0, 1. Okay, so that one was actually very straightforward. Again, use a ruler. Don't do these squiggly lines. For some reason, when drawn diagonally, it doesn't make that straight line. But again, a disadvantage of this method was, for example, if I drew a line here, let's pretend this is line 1, and then I started to draw line 2, okay, and you'll say, well, it doesn't intersect yet. You'll start to see it will eventually intersect somewhere around this area. You just got to keep going, right? So if you run out of grid space, this might be a difficult task. However, this is one of the disadvantages of graphing method, is that you just have to keep going until it eventually intersects. Okay, luckily for us, this one was pretty straightforward. Okay, so this is our graphing method. Okay, perfect. So I'll focus then on substitution method. Okay, so substitution method is actually in section 5.2. And in 5.2. And for this one, what I'm going to do is I'm going to select page 309. We can do number 3A. Okay, so with substitution method, basically what we have here is we have two equations. So x plus y, we'll call that equation 1, is equal to negative 2. And then for equation 2, we have x minus y equals 6. Okay, so you'll notice the setup of them is in standard form, where x and y is on the left side, and on the right side is a constant. Okay, so it's just any number that's given to us. So for this one, we need to decide which variable we want to isolate. So you'll notice, well, we have x and y in the first equation, and then x and y in the second equation. So you just basically have to make that decision. I'm going to manipulate equation 2. Actually, let's manipulate equation 1. So I'm going to isolate for x. Okay, so if I want to isolate for x, I need to move over that plus y to the right side. So what I really have is negative 2 minus y, or x is equal to negative y negative 2. It's the same thing, just rearrange. Both terms are negative. Okay, so this means that I'm going to use this cut and paste method. So you'll notice how in your second equation, you do have an x. And what we're going to do is we're going to take that rearranged portion from equation 1, and we're going to sub it in for x. Because this says x is equal to negative y minus 2. Well, that also can be interpreted as a substitution for that variable x. Okay, so just think of sports. Whenever there's a substitution made, because that's the coach's decision, one player is coming in for another player. So this box player over here on the right is going to come in for player X, because they both represent the same position, right? In hockey, a goalie can come in for a goalie. That makes perfect sense. So what I'm going to do here is I'm going to rewrite equation 2. So x minus y equals 6. Instead of x, I'm going to replace it with negative y minus 2 minus y. So that just replace x. I will just highlight it so you're keeping track of everything. Is equal to 6. Okay. From there, I'm going to collect like terms. So that's going to be negative 2y minus 2 equals 6. I'm going to swing over that negative 2 over the equal sign. So I should have negative 2 is equal to 6 plus 2. Divide by negative 2, divide by negative 2, y is equal to negative 4. Okay, so once I have y is equal to negative 4, I have one of the variables solved for. So I'm going to go back to my original equations. I'm going to play with the other one now. I'm going to use, let's say, equation 1. I'm going to rewrite x plus y is equal to negative 2. So since I actually have the answer to what y is equal to, and we got negative 4, I'm going to sub in y in for negative 4, or negative 4 in for y. So it'll be x plus negative 4 is equal to negative 2. So, there we go. Okay, so now we have a point of intersection at 2, negative 4. Okay, now to really verify and check, we should make a left side, right side statement, where the left side and the right side's put into a check. We're always going to use our original. So, sure, I can go back to equation 2. You can pick any one. You could have picked x plus y equals negative 2. You also could have picked x minus y is equal to 6. So, let's pick x minus y is equal to 6. Okay, so now I'm going to actually use what I got for x. So I got x as 2. So I'm going to sub in 2. I got y as negative 4. So 2 minus 4 is 6. So you see my left side does equal my right side. So I would have to do a therefore statement. The POI is at 2, -4, verified by left side equals right side. Okay? So this is your substitution method. I know it looks a little tricky. Again, you're welcome to try a couple questions on your own on page 209, not 309. Okay, so page 209. And have a look. Okay? So I'm going to do one more. I'm going to focus on your elimination method. Okay, so your elimination method is your third method. Okay, so for elimination method, this one is a little tricky. Okay, and the reason why it's tricky is because you can do addition or subtraction, but really it depends on how your equation is set up. Okay, so your idea, I'll do page 216, number 1A. Okay, so your idea in elimination method is to eliminate a variable. So x plus y is equal to 2. 3x minus y is equal to 2. Okay, so you'll notice if you look vertically, the x's are aligned going down, the y's are aligned going down, the equal signs are aligned going down, and the constant on the right is aligned going down. So between those two variables and your constant, you want to only focus on the variables. And you want to ask yourself, are you going to eliminate x or eliminate y? In this case, it is easier to eliminate x. And the reason why it's easier to eliminate x, and I'm going to put a fancy box around it, is because if you look, plus y minus y gives you a zero pair. Okay, so we want to figure out how to cancel any of the variables that are in that box. Okay, so what I would do in this case is I'm going to cancel my y's. Now, to cancel my y's, I do this through addition. Because if I do y plus negative y, that creates 0. So that cancels. That's what I want. That's what I'm trying to achieve. So if that in fact cancels, when I add 3x plus 3x plus x, I get 4x. 2 plus 2, I get 4. And then, to isolate for x, I just divide both sides by 4. Now, I'm going to take that plus positive 1, x equals 1, and I'm going to sub it in to my original equation 1. Okay, so I have x plus y is equal to 2. So instead of x, I'm going to replace it with 1 plus y is equal to 2. Y is equal to 2 minus 1, y is equal to 1. Okay, so I possibly have a POI at 1, 1, 1. Okay, we still got to do our left side, right side check, just to make sure. So this always verifies. So I'm going to have a look. I'm going to play with equation 2 now. So 3x minus y is equal to 2. I'm going to sub in x for 1, sub in y for 1, play with those numbers. 3 minus 1 is equal to 2. In fact, my left side does equal my right side. So this means that your solution is correct. If your balance at the very end does not balance, that means that it's not right. Okay, that means that you had some error earlier in your equation. So whether maybe you just isolated wrong or eliminated wrong, your left side, right side check has to always balance. Okay? So we'll say, therefore, the POI is at 1, 1, verified by left side equals right side. Okay? So that pretty much wraps up the graphing, substitution, and elimination method. Okay, again, you are more than welcome to have a look and read through, skim through the chapters in your textbook. So that's chapter 5, page 194 onwards. Okay, basically these 3 concepts are covered in 5.1 to 5.3. Okay, so if you haven't yet, make sure you go through your modules. Thanks for watching the video, and I'll touch base again with you tomorrow when we do a new concept. We're going to move into our chapter 6, which is on quadratics, a more important or significant concept that we talk about. Okay, thank you.